And welcome back to our second part of our lesson on dividing of rational expressions. We're looking at example 3. We're looking at 3a and 3b respectively. For question example 3a, we have 2ab divided by 5c divided by 14a squared b squared over 15c squared. And we're following the same rules of factoring. We've done that. So then we continue on, right? And notice we state the restriction by looking at the denominator of those variables. In this example, that's c, and this c, a lot of you realize c can't be 0. So some are saying, what's the big deal? But you have to remember how to deal with fractions, right? What do we do when we divide by fractions? Well, we multiply by the reciprocal. So notice the first fraction stays the same. The division means flip this expression. So we actually have 15c squared divided by 14a squared b squared. And that's why I wrote it in blue. Maybe some of you can't read it at home. It says, check for more restrictions. And I would recommend that you do it this slowly. Some students in grade 11, they think, well, they can see it, they might just jump to it. And you hopefully might see what I'm talking about with our second example. But as I say, some students can definitely see, well, the restrictions are 0 for C and for A and for B. So we just add those in. So A, B, and C can't be 0, because I actually have this line. But then now we start dividing out. Let's do this really quickly. 5 divides out 5 by going there once. 5 goes into 15 3 times. The 2 goes into 2 once. 2 goes into 14 7 times. And then we gotta start dividing out the variables. C goes into this c squared once. And this a and this b respectively goes into those as well once. So what is our final answer? And again, I know it looks messy. So what we're going to get is 3c in the numerator, and in the denominator 7ab with those restrictions. Any questions from the class? Does that make sense? Okay. So the point here was to check that there actually might be more restrictions. So our final example, example B, we have to factor first. So I might need more room. So I think a lot of you realize for this one, 3x, and no, sorry, 3x and yeah. 3x is 1 times x plus 2. And in the denominator here we have x times x minus 6 divided by x plus 4 times x plus 2. And this one here we have x minus 6 and 4. I think that's right. Let's double check my factoring here. I did this relatively quickly. Did I make mistakes? Thank you. So the restrictions from this line, now we're in step 2, state restrictions. X can't be equal to, I'll just mention it, 0, 6, that's not a 6, that's negative 4. 0, 6, and negative 4. But with division again, it means to multiply. And obviously the fraction that we flipped, which was the second one, always we multiply by, or we flip the subsequent division questions. So there might be, this one's the negative 4, and this one is the negative 2. So the restrictions are, hopefully it's on the screen. Yeah, I got it. 0, 6, negative 4, negative 2. Any questions about the restrictions that I just did? And then now notice, after we do step 2, we start simplifying. That's when we start dividing out. So this x minus 6 and this x minus 6 down here. This x was 4 and this x was 4. 2, and this x plus 2. And so I think our final answer is, and I apologize, it's, hopefully you guys can see it at home, 3x plus 1 over x. Any questions from the class that's here? Any questions? No.
So the rational expression we're dividing by, do we apply the restrictions to the denominator of that, like in the second step, you have x minus 6x over 4. Would the restrictions be applied to that, or are they only applied once you flip it?
So good question. The reason why it applies in both situations, because look at the original question. If x was ever 6, let's take a look at this one, right? So I factor. If x was ever 6, this denominator would go by 0, right? And you can't divide by 0. I mean, it causes mathematician problem. That's the whole problem. So that's why it seems like it's not a big deal. But in the original, if x was ever 6, this would go to 0, right?
You can't divide by 0 within that one.
You can't divide by, exactly. This is so. But then when we, even though I interchange division, we multiply. Notice, hey, the 0 is not bothering, but there's more restrictions. Because now in this concept, like even if you were to flip it right away, that's what we're worried about. If you flip this too early, that's why these are the fundamental rules. This is the order that you're supposed to go. If you flip too early, then you might miss out on a restriction. That will cause problems. And in mathematics and in science, this is huge. So we have to be methodical, right? Yeah. So it's actually, that's actually a very good question. Because some students say, well, why don't we just do this? That's what we're taught in rational numbers. But that's why with rational expressions, we have to factor. Yeah. Anyone else have a question? That was actually really good. Any questions?